The Semel Institute here at UCLA is a large institute that studies psychiatric disorders as well as some normal processes in the brain to understand brain and mind and also the disorders thereof. And within the Semel Institute, we have a center, the Tenenbaum Center for Creativity, that I'm a part of. One of the things that we're doing here in my group is we're studying children who are very highly to profoundly gifted. So these are children with IQs of 145 or greater who are exceptionally bright. They do not do well in a normal classroom. They need to be in a specialized classroom that appreciates their special gifts and encourages them to express their intelligence. Children like this who do not have the opportunity to be in these kinds of classrooms can really have a lot of problems as they get older, and they certainly don't meet their potential. So we're studying these children using fMRI as well as some other MRI techniques, including diffusion tensor imaging, which helps us track the white matter pathways of the brain so we can see how those connections are formed in these kids and how they might be different from typical children. Interestingly, we know almost nothing about what is happening in the brain to make certain individuals extraordinary. We have no idea what it is that's different about their brains to make their IQ so incredibly high. So that's what we're trying to do. We're doing some tasks that involve this kind of complex reasoning and problem solving, integration of very complex concepts, and trying to see how is it that their brains are working when they try to solve these problems. How are they integrating information that's different from the way that typical children integrate information? How are they communicating across brain centers? Is their whole pattern of communication fundamentally different? Do they just integrate information more or more solidly? Is the hardware different? Do they have a different number of neurons, or do they have thicker cortex, or do they have more white matter? We just know so little about this, and that's what we're trying to study right now. We're studying children in particular because they're very young. They haven't had all of these life experiences that can also shape brain growth and brain development. They're still young enough so that what they have is the brains that they were endowed with, and they're just starting on this process of learning to fill it with all the information that they're going to learn in school.